Okay, hi there. Welcome to Introduction to Process Control. This is the first lecture in a series in a course intended to introduce you to process control and automation. My name is Dave Shook, and this course is the result of teaching for a number of years, both in the university and industrially. First of all, it's important as an adult to consider whether you need to take a course or go through a module. In this particular module, we're going to be going through and defining these terms. If you already have an understanding of these terms, feel free to skip to the quiz that comes after this and see how well you do. And if you understand everything, then you don't need to go through this material. Concepts that we're going to be dealing with in approximately this order. So first of all, I want to talk about feedback. Now, feedback is one of those terms that is used in common everyday use with one of those implicit definitions that people are somewhat familiar with, but not necessarily have a specific definition. In control, feedback has a very specific definition, and that's what we're going to be talking about now. So feedback in control is the use of the controlled variable as an input to the controller in order to control the value of that controlled variable. Now, rather than give you those string of words, it's better to do this with a picture, or rather a series of pictures. So first we're going to start with the concept of a controlled variable. And in fact, first we're going to start with the concept of a control system. So an example that most people are familiar with is controlling the speed of a car or a bicycle, some vehicle, where you have a desire to control the speed of that vehicle. So if we take cruise control, so automatic speed control in a car, we will start by measuring the controlled variable. Now, the controlled variable is the variable that we are interested in maintaining at some value, even though it is going to be subject to various types of input that we have no control over. So in this case, that's speed. And we start by measuring that. Now, it's important to distinguish between the true speed over the ground and the speed as measured, because there are imperfections in that speed sensor, and sometimes from an analysis and troubleshooting point of view, we need to look at what's wrong with that speed sensor. So we draw this block diagram, which is our graphical language for communicating control, and we distinguish between the raw speed, the true speed, and the measured speed. That measured speed is then compared to a desired value or set point. Set point is another term that we use, and the set point is the value that you want your controlled variable to be at. So if you're driving on a road where the speed limit is 80 kilometers per hour, then your set point will probably be something around 80 kilometers per hour. It's the desired value of the controlled variable. Then we compare the two. We take the difference between the speed set point and the measured speed, and that gives us a control error. That control error then serves as an input to the controller, which is embodied in a computer these days. Once upon a time they were physical boxes, but these days it's really a chunk of code in a computer. So this controller calculates a desired throttle position. So data in to data out. Now, this desired throttle position is sent to some physical equipment that affects the process. This physical equipment, which is generically called the final control element, is an actuator. It's a device that takes a signal and converts it to some physical mechanism, some physical event or value in the real world. In cruise control, it's an actuator that moves the position of the throttle valve, which changes the amount of air-fuel mixture that goes into the engine. That is then an input to the real world. That valve position affects how much power the engine can generate. The transmission determines what gear you're in. The wheels determine how far you go per revolution, and associated physics involving wind and slope and so on, which are your disturbances, affect the speed. So here we have feedback from the measured variable directly all the way around a closed loop So we start over here at the speed. That value is fed all the way around to where it started again. So we end up with information flowing around a closed loop. So this is feedback from the purposes of control. Our controlled variable, speed, becomes an input to the controller, which then affects the controlled variable. There are other forms of control which do not involve feedback, and we'll be getting to them later in the course.